All right, welcome everyone. If you're an engineering leader or an architect in the automotive space, you are in exactly the right place. This is your strategic briefing on where EV charging is headed. We're going to deconstruct the massive shifts happening right now, all the way from the plug to the cloud, to give you a clear, actionable roadmap for the next 6 years and beyond.
Okay, let's just jump right in. If there is only one thing you take away today, please let it be this. Charging is no longer just about filling up a battery. Not even close. The entire paradigm is shifting right under our feet. We're moving away from a simple one-way flow of electrons to a really complex bidirectional hub where energy and critical data get exchanged. This isn't the future. This is the new reality we have to design for.
So here's how we're going to tackle this. We use a classic top-down approach. We'll start with that big picture paradigm shift. Then we'll apply a MECE framework, mutually exclusive, collectively exhaustive, to break the landscape into 3 clean, distinct battlegrounds. From there, we'll dive deep into the hardcore engineering of megawatt power, then the intelligence layer of software, and we'll wrap it all up with a concrete strategic playbook you can start using tomorrow. So, what is this fundamental shift really? Well, it's not just one thing. It's actually a powerful convergence of 2 very different but equally important market demands that are pulling the technology in fascinating new directions.
See, on one hand, you've got the commercial vehicle sector. For them, it is all about uptime, efficiency, pure and simple. They need megawatt-level power to get a 40-ton truck juiced up and back on the road within a driver's mandatory rest break. But on the other hand, you've got the passenger car market, and that's all driven by user experience. Your average customer, well, they expect the same slick, secure, and totally automated experience from their car that they get from their iPhone.
Now, to really make sense of all this complexity, we can use a really powerful strategic tool, the MECE framework. This helps us map the entire landscape across 3 distinct but deeply interconnected domains where all the real innovation and competition is happening right now. And these 3 battlegrounds are, first, the power dimension. This is the raw engineering race to deliver megawatts of power. Second, you've got the protocol dimension. This is where we see this really interesting conflict between all these different physical plugs and a single unifying software language. And finally, the ecosystem dimension, which is this explosion of new players, from grid operators to mobility providers, who all need to talk to each other securely.
Okay, let's start by digging into that power dimension. This is where the physics gets pretty extreme, and it's driven almost entirely by the tough, uncompromising demands of the heavy-duty commercial trucking industry. So here's the crucial point. Logistics is a game of minutes. In Europe, regulations say a truck driver must take a 45-minute rest after 4.5 hours on the road. Today's 400-kilowatt fast chargers, they just can't fill up a truck's battery in that time. That creates what adds up to a 7.4% loss in operational time, which is huge. But the megawatt charging system, MCS, it's designed to perfectly nail that 45-minute window. 0 time lost. For logistics, this is an absolute game changer.
And this number right here, it perfectly illustrates the core engineering problem we're up against. Pushing this much power isn't really about the voltage. That's around 1250 volts. No, the real challenge is managing an absolutely staggering 3,000 amps of current. I mean, think about that. That much current generates an immense amount of heat that you just have to deal with somehow.
So how do you solve for that? Well, there are 2 strategies that are completely non-negotiable. First, you need aggressive, active liquid cooling. And I'm not just talking about for the cables. It's mandatory for the charging inlet on the vehicle itself. Second, you have to split that massive current as early as you possibly can. As soon as it's inside the vehicle, the power distribution unit has to divide that 3,000 amps and send it to multiple battery packs. You have to do this to stop any single component from getting hit with the full thermal load.
And even when you do all that, the losses are still significant. Our system-level analysis shows that during a 1 megawatt charge, even on an 800-volt system, the biggest source of energy loss, we're talking over 7%, is just the internal resistance of the battery cells themselves. The next biggest energy hog, at almost 2%, is the cooling system itself, working overtime to manage all that heat. At the end of the day, only about 90% of the energy you're pulling from the plug actually makes it into the battery.
All right, let's switch gears now, from the raw physics of power to the brains of the operation. This is the intelligence layer we talked about, the software, the communication protocols, and the security frameworks that make this whole complex ecosystem actually work. And what we're seeing here is a fascinating paradox. At the physical layer, the actual plugs, things are fragmenting. North America is rallying around NEX, Europe is sticking with CCS2, and China and Japan are pushing towards Chao-G.
But look underneath that at the logical layer, and the complete opposite is happening. The entire global industry is converging on one single unified communication protocol, ISO 1511-20.
And you can't overstate this. ISO 1511820 is a huge leap forward from the old -2 version. For starters, security isn't optional anymore. It mandates the much stronger TLS 1.3 protocol. And critically, it's the only standard that natively supports bidirectional power flow. That's what enables things like vehicle-to-grid. It also lets you handle multiple charging contracts in one session, so a driver could, say, switch from their personal to their company account without unplugging.
So what makes all this possible? Well, the entire architecture of trust that enables this secure, automated world is built on something called Public Key Infrastructure, or PKI. You can think of it as the system of digital passports and cryptographic keys that gives every vehicle, every charger, and every operator a trusted digital identity. That's what lets them all transact securely without you ever having to pull out a credit card.
Now, given how incredibly complex it is to implement PKI and keep up with these evolving standards like 1511-20, trying to build a compliant software stack from scratch, well, it's a massive risk and a huge undertaking. This is why a buy over make strategy makes so much sense here. Using a pre-integrated, validated commercial software stack can literally slash your development time by as much as 40%.
So, after looking at the power, the protocols, and the ecosystem, what does this all mean for your engineering strategy? We've boiled this entire analysis down into 4 clear, actionable imperatives for you and your teams.
Okay, here we go. Number 1, commit fully to ISO 15118-20. It's time to stop over-investing in legacy standards. This is the foundation for next-gen features like V2G and MCS. Number 2, build your software to be hardware agnostic. Your communication stack should not care if it's connected to NACS, CCS, or whatever comes next. That needs to be a configuration change, not a painful code rewrite. 3. Treat MCS as a complete systems engineering challenge. You must simulate the entire energy and thermal flow, from the grid all the way to the individual battery cell. Don't just focus on components in isolation. And finally, number 4, invest in PKI operations. Your ability to manage the lifecycle of digital certificates, that's not just an IT problem anymore. It is a core competitive advantage that completely defines your customer's experience.
And that really brings us to the final critical question you need to be asking yourselves. The game has fundamentally changed. So the focus has to shift from just engineering isolated components, a plug here, a controller there, to architecting an integrated, software-defined system that delivers a real competitive advantage. And that, right there, is both the challenge and the incredible opportunity ahead of us.